this video, we'll be talking about the flow and velocity diagrams available in the Mechanical Productivity Pack. So we've talked about modeling some ductwork. We've talked about generating layouts. We haven't talked yet about air terminals and mechanical equipment, but really this all comes together with getting your loads done, getting the airflow, the calculated airflow into Revit, either running the loads in Revit or using GBXML to get that. And then once your air terminals have the proper airflow and systems are connected, then we're able to use Revit to size those systems. So if connections aren't made, if parameters aren't set up, connectors aren't set up correctly for flow propagation, none of this is possible. So this is all based on that all being set up. So in the view browser, we have an analysis category for views, and this is basically used or set up for designers to go and look at flow information in the model after connections have been made. If I expand out HVAC here, you can see that we have a handful of different views with legends already applied, set up for HVAC and for hydronic piping and for plumbing as well. So these views have legends that are applied to them, which you can edit. So we have different colored fill strategies set up based upon what type of view. In this particular one, we're trying to flag sections of ductwork that have 0 CFM. So we're saying show us any ductwork that has no flow or less than 5 CFM. If it has 5 or more, then it's blue, and then users can just disregard it. So it's real important. It's actually very helpful to be able to use the duct sizing and pipe sizing in Revit, but before you can get there, you have to know that you have the proper airflow in the systems. So we'll be talking about that in this video and going over a couple examples. If you don't have things connected and if you don't have airflow in the duct systems, then using the duct sizer tool in Revit isn't beneficial at all to you. However, for the last 10 years, I've used a duct delator and I've used a lot of stuff outside of Revit, but now having the information inside just makes me that much faster and more efficient sizing the ductwork. So let's talk about some things that these views will flag. So in this given view, this is a no flow condition. So it's looking for 0 CFM. So as you can see, where the last takeoff occurs on a section of duct and where the duct is capped, there's going to be 0 CFM there. So that's a normal situation to see on projects. Let's go up to the second level. All right, so second level, we got a whole bunch of stuff going on now. So first I'd like to highlight where you see sections of red and then blue and then sections of red. This is a common occurrence when air terminals are connected. However, there's an open end in the duct and the airflow doesn't know where to go. By selecting a duct and looking at System Inspector, you can hit Inspect. You can actually see that the airflow arrows here, which are pretty faint, but they don't know where to go. The airflow comes this way, but then right here it doesn't know where to go. Same with this path. The airflow doesn't know where it's going. So this is a common situation where you are missing some caps on your duct. So we could investigate this end. Okay, that end has a cap, and we could investigate this end, and sure enough, there's no cap there. So as soon as you cap this, now your ductwork system has the flow that's needed. I see we have some other issues here. Oh, that's interesting. So we still have some connections here going on, and I'm wondering if there's some disconnects. I'm gonna stretch this duct out for a second. Oh, that's a trend. Oh, and now it's updated. So I guess Revit just needed a moment to update. Here's a situation where we have an energy recovery unit with exhaust air going up, which has flow. Now the airflow from the unit itself does not have flow because it's tying into a return duct system. We're still playing around with different types of takeoffs and fittings we can do here to merge those systems, but at the moment that's not set up. Here's another situation of a section of red and then sections of blue. So this kind of looks like it's a duct without a cap on it. So sure enough, we go down here. I don't see a cap. I'm going to select the duct and cap it. All right, so now that duct has flow in it. The return duct just the same, so anywhere where there's a cap and after the last takeoff, that'll be zero flow. So that's a normal condition. So now let's look at velocity in some of these sections of duct. I'm going to expand out HVAC again. Let's go down to the first floor. So you could update these color legends to be whatever your firm desires. So you can just select the legend, you can hit edit scheme, and then you could update these numbers. So say for example your firm wanted to say gray is everything up to 800 feet per minute. You could change this to 8, and that updated. And just like that, you can update the legend in that sense. Okay. So you'll see this a lot in the velocity diagrams. A lot of times when you connect to diffusers, you'd be surprised, but actually the neck size is actually a very low pressure drop typically for a lot of diffusers. So when I look at these velocity diagrams, I end up seeing a lot of gray throughout, which isn't necessarily bad. Lower velocity is less pressure drop, less fan energy, all of those types of things, less static pressure drop. So there's benefits. However, say we were trying to design everything under 1500 feet per minute tops, maybe even lower than that. We see some sections here that are too small. So we could select this particular duct and we could increase the size of it. And there we go. Now we fixed that given issue with velocity. So some of these views get plotted off for during quality control. In some firms, when I'm reviewing a project, I'm actually in the model looking at these views, but these could be plotted off for people or put on a PDF for people reviewing outside, and then they can see the integrity of the model. How well have connections been made? Is flow propagation throughout the systems or not? Let's go up to the second level and talk about a couple situations. So let's actually talk about some duct sizing tools now. So we have a VAV box here and we have some higher velocity sections of duct. You can select a section of duct. You can actually select as much as you want, and you can size all of that duct system. It all depends how you want to do it. So in this case, I'm just going to select the duct up to the T, and we're going to go and look at duct pipe sizing. So you have a handful of options here you can size off of: friction, velocity, equal friction, and static regain. So in this case, I'm going to choose a friction pressure drop. 0.08 is a typical number that a lot of firms design off of, which would be considered lower velocity, low pressure drop design. So it's going to be a little bit more sheet metal, but once again, lower pressure drop. So fan energy savings, quieter airflow since it's lower velocity, that type of stuff. And you could give the velocity a high limit as well. You could say only, or you could say and. So I'm going to design off of 0.08 and 1100. And these will flip which one controls what as you get to larger duct sizes. So now for branch sizing, we can say calculated size only, match connector size, larger of connected or calculated. Typically I use larger of connected or calculated. So like at a VAV box, that will size this branch ductwork what it needs to be, and then it'll reduce down to what the VAV box size is. And then we could restrict the height. So maybe let's put this at 14-inch height, and let's hit OK. All right, so we just sized that section of duct now based upon that criteria. Now let's look at the round duct feeding up to the VAV box. We could select that. We could tab over that and select that. Duct pipe sizing. So once again, we can give it, we can restrict the height. This is a round duct, so I'm not going to restrict the height in this situation. And I'm going to say larger of connected or calculated. We'll do the same thing. And there we go. So, it put a reducer in there down to the VAV box. And now we have an 18-inch size for that given amount of airflow, which for verification purposes is 1380 CFM. So here was that duct that we used for generate layout in the previous video. You can see we have some higher velocities in here. So you could select this duct and size it. Before I do that though, I'm actually going to put some brakes in here because I want to change the sizes as airflow drops off. So I'm going to put a brake right here. And we're going to put a brake down here after these diffusers. And now, I'm just going to select the entire network. And we're going to size the ductor pipe. So now in this situation, I don't want to size these branches out based upon a velocity. So I'm going to say just match connector size. I am going to restrict the height. So this duct width now, I don't want taller than 14 inches, and then it'll size the width according to this criteria. So let's hit OK. And there we go. We've used Revit now to size the branches and the duct mains. As you can see, a reduction here was made in duct size, and then also here where I put those unions. And so you can update these sizes now as you needed. Now that you have connected airflow, you can actually use it, which is a huge benefit. So something else I want to point out in Revit. So Revit looks at connected airflow in the duct systems. So in this particular, so I guess you need to be aware of block airflow and peak airflow and what your design is. There's a lot of firms out there that will design their fan systems and their ductwork systems off of block airflow. Because the west zone of a building is going to peak at a different time than the east zone. So peak airflow would be adding up all the airflows and calling that your total. Block airflow, says that, hey, this box is going to peak at a different time than this box. And if you run your load calculations, it's very easy to determine what the block airflow is, and then you size your ductwork system off of that. So with using Revit's duct sizing tools, you just need to be aware of that. So when you get to a section of duct that now contains all of the airflow, Revit's going to see the peak airflow, and if you're sizing off block airflow, you necessarily don't want to use this particular duct pipe sizing tool to size that. So like this return air duct was one of those situations. So it's just something to be aware of when you're using these duct sizing tools. So just showing you right here, this supply airflow is 7610 CFM. However, if I've sized my system for less than this is peak airflow, so I might not want to use Revit's duct sizing tools. So this was more on the ductwork side. We have the same thing for hydronics. So first and foremost is make sure you have flow in your system before you're able to use Revit to size it. So looking at this hydronic piping diagram, you're able to see, any locations that have issues with flow, and then you can go and use Revit sizing tools. So I hope you guys enjoy these legends, and I hope you expand on them more for your company.